Hi friends, in this video the topic is starting methods of synchronous motor. Because synchronous motor is not a self-starting motor, that's why we have to start by using any auxiliary methods. That's why we came here to discuss the starting methods of synchronous motor. In that we have many methods. That is first one, auxiliary motor starting. This is the first method. And second method, pony motor starting. Be careful, this is not SONY, this is PONY. Pony motor starting. And next one, damper winding starting. Damper winding by using VISA already. And next one, induction motor starting. Those two are there. So let's discuss about first these two things, auxiliary motor starting and pony motor starting. Let's see, actually my synchronous motor is like this. For easy understanding, I am taking two-pole machine, but in generally the two poles are not possible for synchronous motor because this is a silent pole type. In silent pole, minimum is the 6, maximum is the 120 poles, you know that. So whatever, let's see here. I am going to start my synchronous motor. For that, listen carefully what I am doing here. First of all, I am giving 3-phase AC supply to the armature. When 3-phase AC supply given to the armature, ultimately it will produce rotating magnetic field which rotates in clockwise direction with the synchronous speed. Yes or no? Nothing but here north pole is created and here south pole is created. These poles are rotating in this way. Okay. During this case, during starting condition, this field winding should be shorted with the resistance value, because if this is living like that, this flux may links with this conductors, rotor conductors, because this is now stationary and this is synchronous speed, so we have a relative motion. So EMF will induces in the field winding, which large currents flows in the field winding, which damages the field winding. To avoid that large currents which are induced in the rotor, because of that we are placing a rheostat or resistance across the field winding. Okay, so I connected a field winding during starting condition. Just I given 3-phase AC supply and connected to the field winding connected to a resistor. Now this rotor should be connected to a auxiliary motor which having the constant speed. It should have constant speed and rotate this rotor in the same direction with the same speed of magnetic field. That's why we have to take here constant speed motor. Can you tell me what is the constant speed motor? Yeah, exactly. Here DC shunt motor is more preferable. Here auxiliary motor is nothing but DC shunt motor. So right? Auxiliary motor is nothing but DC shunt motor we are using. Because this is a perfectly constant speed motor, by the speed of synchronous speed, we are rotating this rotor in the same direction with same speed. Now this field winding rotates at synchronous speed and my field also rotates at synchronous speed. What is the relation between this rotor conductors and the field? 0. Now we can remove this switch. Actually, we have a switch. Remove this switch and connect it to a DC supply. This field winding is now excited. When my rotor is rotating already in synchronous speed by using this auxiliary motor, and my, what is this? This is also the magnetic field also rotating at synchronous speed. Now I am giving DC supply to the field winding. For example, here I got that south pole and north pole. It should be like that. Here, this rotor poles and stator poles both are rotating with same speed in the same direction. After particular time, what happened here? Unlike poles, what will exist in between unlike poles? Attractive force will exist. So these unlike poles are attracted each other. These two are attracted each other. After some time, this attractive force converted as a magnetic lag, magnetic locking. This force is nothing but the magnetic locking. So when these rotor poles are magnetically locked with the stator poles, then my rotor is rotates at synchronous speed even though the auxiliary motor is disconnected. Of course, you can disconnect the auxiliary motor after magnetic locking. So the synchronous motor is works on magnetic locking. Listen carefully. Here the magnetic locking takes place in between the rotor poles magnetically locked with the stator poles. What happened here? Rotor poles are magnetically locked with the stator poles. Here stator poles rotating in clockwise direction with synchronous speed. That's why our rotor poles also rotates at synchronous speed in clockwise direction. This is simply the auxiliary motor starting. Here auxiliary motor is nothing but a DC shunt motor. Are you clear? Before starting the machine, we should connect it to a resistor. But when the rotor is rotated at synchronous speed, then this resistor is disconnected and connected to an exciter, which is DC shunt generator. Right. This is the first starting method, auxiliary motor starting. Next, second starting method, pony motor starting. What happened here? The pony motor starting is 100% similar to the auxiliary motor starting. What is that? 100% similar to the auxiliary motor starting. The only change, so don't say 100%, 99% similar. The only change is that here we are using not auxiliary motor, not DC shunt motor. What we are using? Pony motor we are using here. This is the only change. So what we are doing? Take the synchronous motor and three-phase AC supply given to the stator. Then magnetic field created which rotates in clockwise direction with synchronous speed, and connect this field winding to the resistor at starting condition. Then this rotor connected to the pony motor. This pony motor rotates the rotor in same direction with same speed. Then this is disconnected and DC supply is given to the field winding. Then poles created. After some time, this attractive force is converted as a magnetic locking. Then after, even though pony motor disconnected, the rotor rotates at synchronous speed. Everything is same, the story. But here the DC shunt motor is replaced by the pony motor. Sir, what is that Sony, or sorry, not Sony, pony motor? What is that pony motor? Here, pony motor nothing but small induction motor. Why we are choosing only induction motor? It may be the speed near to equals to synchronous speed. We can make it like that. So small induction motor, the poles of this small induction motor, can you tell me how many number of poles are there in this pony motor? The poles of pony motor is equals to poles of main motor. Main motor nothing but synchronous motor. Poles of main motor minus 2. This is the very important point. In this pony motor, the poles are 2 less than the main motor. Now some fellows having very important doubt. Sir, if my synchronous motor having 2 poles, then what is the situation? If you ask this question, they will give you Nobel Prize for asking you, for listening me. Both you and me, both are eligible for Nobel Prize. Okay, I said you many times, generally 90% of motors are silent pole type. In silent pole, minimum is the 6. 2 is no question. Minimum is the 6 poles. But in generally, we are using 10 to 20 poles. I said you many times. Again, don't ask to anyone, sir, if in synchronous motor we are using 2 poles. They will laugh. Okay, right. So, pony motor, sir, why it should be less than 2? Less 2 number. For example, in our synchronous motor, I have a 12 poles. What is this? This is the synchronous motor. For 12 poles, what is the synchronous speed? 120 F by P. So the speed is 500 RPM. In pony motor, I have a 10 poles. 10 poles, nothing but what is the synchronous speed? 120 F by P, so is a 600 RPM. This is 500, this is 600. But this is a induction motor. Induction motor, always the rotor speed less than synchronous speed. This is not equals to synchronous speed. So what is less than 600? Less than 600 is the 500. We can make it at 500. So if both are rotating at 500, then the magnetic locking is easy. Because here the induction motor is rotating at 500 and this synchronous speed, the magnetic field also rotating at 500. Easy to synchronize, easy to magnetize. Sir, for example, if you take a 12 poles for pony motor, what happened? If you take 12 poles to pony motor, the speed of the synchronous speed of the induction motor is 500, but always the rotor is rotates at less than synchronous speed. For example, 450. Here, rotor is rotating at 450, but magnetic field is rotating at 500. My rotor is at 450, my magnetic field is at 500. Is it possible to magnetic locking? If the rotor is very sharp, if it is trying to catch the magnetic field, then the machine will damage. Don't do like that. So we should take here 10 poles, 2 number less than main machine. This is simply about pony motor and axillary motor, very simple. Now we have a third and fourth one, damper winding starting and induction motor starting. Are you okay? Right? So let's see the damper winding starting. Third case. What is the third case? The third heading or third starting method is damper winding starting. You know, the poles of the pony motor is equals to poles of the main motor minus 2. You should remember that point. Next one. I said you already, generally the damper winding is used for silent pole motors only. In cylindrical motors, the rotor itself acts as a damper winding. This damper winding is a short-circuited winding. This damper winding placed under pole shoes. This damper winding made up of copper alloy, brass or branch, etc. like that. I given you already. What I said you, damper winding placed under pole shoes. This is a short circuited winding, and this is made up of high resistive materials like a copper alloy, right? When the three-phase AC supply given to the our winding, then it produces a rotating magnetic field which rotates in clockwise direction with a synchronous speed. But here the rotor is not start rotation up to now. Of course, we have a field winding, but this is open circuited, not given now. So when this is zero speed, here NR is equals to 0, but NS is equals to, for example, 1000 RPM. There is a change in speed. Nothing but there is a hunting. If there is a hunting, what happened? Then the ED, damping EMF will produces. Damping EMF will produces in the damper winding. Then this damping EMF finally produces the damping torque. I said you already. This is the case 2, NR less than NS. This damping torque, what happens, sir? Increases the rotor speed up to synchronous speed. Okay, this is increase the rotor speed up to synchronous speed. When it reaches to synchronous speed, then the damper winding produces no torque. At that condition, we have to give the DC supply, and here poles created. After some time, magnetic locking will develop. Due to magnetic locking, the rotor rotates at synchronous speed. Up to magnetic locking, the damper winding in action. When the magnetic locking is there, then the rotor is equals to synchronous speed, then the damper winding produces zero torque, it will goes to rest position. So in synchronous motor, damper winding used to eliminate hunting and for starting purpose. Here two purpose. But in alternator, damper winding used to eliminate hunting, that's it. But here the damper winding used to eliminate hunting and for starting purpose both. And tell me, this damping torque is called, here NR is less than NS. When NR is less than NS, it produces damping torque which increase the rotor speed up to synchronous speed. This damping torque is called induction motor torque. I said you already in alternators. This is called induction motor torque. This is simply about the damper winding starting. This is well preferable method of starting for synchronous motor. Next, fourth one is there. What is that fourth one? Induction motor starting. In this generally, the synchronous motor started as a slip ring induction motor by connecting extra resistance to the rotor. We know in slip ring induction motor we can increase the starting torque by adding the extra resistance in series to the rotor, right? Here also by adding extra resistance in series to this damper winding or this rotor winding. Then what happens? When the extra resistance increases, the starting torque increases, then automatically the rotor rotates at nearly synchronous speed. After some time, what will happen? After some time, magnetic locking will take place. Then after, the machine acts as a synchronous motor. So, in induction motor starting, initially the motor starts as a slip ring induction motor. And after magnetic locking, the motor runs as a synchronous motor. This is simply the induction motor starting. These are the starting methods of my synchronous motor. In this, damper winding starting is well preferable. If you use auxiliary motor starting, we should buy the DC shunt motor, which is costly. And in pony motor starting, induction motor is costly, but in damper winding it is very easy, and the additional advantage is that as it eliminates the hunting. These are the starting methods of synchronous motor. That's why if you start once, then it will rotate in synchronous speed. That's why we are using enormously in our industry for constant speed applications. Okay, thank you.